What's up, everybody? This is Matt Brown with another IoT hacking video. Today, we are going to be doing something extra special. We're going to be hacking my charcoal smoker. That's right. I got probably what is the most overkill grill imaginable. It has internet, it has Wi-Fi, it has Bluetooth connected. And so we are going to be discovering multiple Bluetooth low energy based vulnerabilities in my charcoal smoker today. I was actually using this earlier today, cooking up some hot dogs and hamburgers, and I've been meaning to dig into the Bluetooth protocol on this device for a while and just hadn't gotten around to it. And I thought, hey, this would be a great opportunity to share with you. And now it's about midnight at time of recording, and I have found at least two Bluetooth low energy vulnerabilities in this device. So let's jump into it and get started. Before we do that, my name is Matt Brown. On this YouTube channel, we tear apart IoT devices. We reverse engineer cool proprietary protocols, all that fun stuff. In my day job, I kind of do this professionally. I find vulnerabilities in devices and present them to you and your businesses. And so if you're interested in that, definitely jump down in the description and check out my website. But without further ado, we're going to jump into this because I am super pumped. So first of all, this is a master-built charcoal smoker, and it is internet connected, right? The idea is that I have this Android app that we're going to be talking about today, and from anywhere in my yard, on the go, I can look at the app and see the progress. I can see temperatures. I can plug in optional meat thermometers and have all that data so that I know that my rib smoking is going good or something like that, right? So we are going to be targeting the Bluetooth low energy side of this device. So just to walk you through kind of the setup process, Bluetooth low energy is used inside of this application to configure your grill to your Wi-Fi, to connect to your Wi-Fi. And at that point, Bluetooth is not used anymore officially inside the application. But we are going to discover ways that we can use it because it is left listening on the device all the time, even though there is a button that you have to press on it to put it into pairing mode. It is actually always listening on these Bluetooth low energy services, which is pretty fun. So what we're going to do first is we're going to discuss a very simple Android and iOS app that you can use to discover all sorts of devices that are around you. So this is called NRF Connect. So I've already scanned and I've already found my charcoal smoker right here inside of our application. And I am going to go ahead and connect to that device. And you see that we have successfully connected because now it says disconnect up here. And we can now enumerate all of the services that are available on this device, right? So for example, under generic access, we can read the device name and it says master built smoker. We can read a bunch of these other things that aren't that interesting. Down in device info, we can get the model number, the firmware revision, the software revision, all sorts of fun stuff. But on most Bluetooth low energy devices, where you're going to find the real interesting services are they're going to show up as unknown service. So in the Bluetooth spec, there are a bunch of predefined services, right? Like, so if you want to make a heart rate monitor, then you don't have to reinvent the wheel. There's already kind of a protocol defined and a characteristic set up in the spec. But most of the time, people don't use the pre-selected ones. They just have their own binary protocols for communicating with their devices, and they're going to use those. So right here under this unknown service, we can see that there's all these unknown characteristics, and this device has 5, and they're kind of denoted by these UUIDs, right? These long strings here, and we see that on our grill we have 5 of them, and we're going to denote them as services 1 through 5 because they end with FFF1, FFF2, and so on down to FFF5. So those services are right off the bat just scanning. I'm not reverse engineering the app. I'm not looking at the packet data yet. Just from connecting to the device and enumerating these services, I can already tell this is what I want to target. I want to know how these services work, right? What can I write to these services? Can I read data from these services? All kinds of stuff like that. So what we're going to do is, I often get this question around Bluetooth low energy hacking. How do I get the packet data? I want to be able to sniff Bluetooth low energy packets. Maybe you have experience doing like Wi-Fi packet sniffing or something like that, or sniffing on a wired network, and you're like, I want to see the packet data so that I can analyze it. How do I get that? And people will bring up things like the Ubertooth or some other kind of wireless sniffer device that can capture packets in transit between two other devices. And there are devices out there that can do that. That is a rabbit hole you can go down, but it is really hard because of the way Bluetooth works to do that packet capture. But the cool thing is, in this situation, we don't have to do any of that. Because we have an Android app, and Android has built-in functions to give you a packet capture of all the Bluetooth low energy packets that are going to your device out to whatever other devices out there. So what we're going to do is we're going to go here. This is just my Pixel that I have that's rooted. None of what we're going to do today requires root, but it does help in some situations. But we're just going to go into settings, and we're going to go into system. And then we have already enabled developer mode, but if your device is not already in developer mode, you need to put it into developer mode. So you have to like go click the build number 7 times. But once you do that, you get the developer options here, and you will need to enable something here. It says enable Bluetooth HCI snoop log. So what this is going to do is every Bluetooth packet that goes to or from your phone, it's going to put it in a log file, and then you can download that log file. So we have enabled that already, and I have already gone through the process of setting this up, right? So one of the things I always want to do, especially because, again, like I said, the main purpose of Bluetooth low energy on this device is to give the grill, this device, my Wi-Fi credentials, so that then it can connect to the internet, and then it'll connect up to some cloud server, and then my phone will also connect to a cloud server, and that way, even if I'm not close to my grill, I can configure it, I can get temperature data, things like that, right? So I already went through the process of setting this up and connecting it to my Wi-Fi. So we are going to go into our shell here, and we're going to use ADB. So I'm going to kind of walk through the process of doing it on a rooted device, but I'll also mention the process of doing it on a non-rooted device. So the file where it exists, like on the system, is this path right now. I'm not in my Android device's shell yet, but this is the path. The problem with doing this on a non-rooted device is it's really weird. You actually have like read privileges on that log file, I believe, but you don't have access to the directory path or something like that. So you cannot directly pull that log. So what you have to do on a non-rooted device is you have to run the command adb bug report, and what it's going to do is it's going to pull down a huge zip file with mostly a bunch of junk that you don't want, but it will contain that snoop log, and then you can throw all the other stuff away, and you can just keep that one file, and you're good to go. But we are going to do it on the rooted device, so what we're going to do is we are going to pop into our shell. So I do have the su program because it is rooted, and then we're just going to go look at that file. Yeah, and you can see it's like world readable. So theoretically, you should be able to pull it down. But what we're going to do is we're just going to copy that file to our SD card right there. And now we're going to pop back to our local shell here, and we're going to do adb pull and then pull our file down. So I already happen to have this file down, so I'm not going to do that right now. And then what you do is, even though this is a .log file, it is a file that you can open directly in Wireshark like this. So right here we have Wireshark, and you may have not experienced opening Bluetooth packet data in Wireshark, but just like any other packet data, it's going to recognize a lot of different protocols, and there's going to be some special filters here, which you can see I already have one selected. So the filter I'm going to use right off the bat is BTATT, and this is going to filter out a bunch of packets that we don't care about, because when we take this capture on Android, we're actually getting the packets, like really low-level packets that kind of communicate between the Wi-Fi chip and the Android operating system, excuse me, the Bluetooth Low Energy / Wi-Fi chip and the operating system. So we want to just filter straight down to the Bluetooth Low Energy packets, and we do that with the BTATT filter. And then we're going to start to look for data. Okay, so this is a Wireshark / Bluetooth Low Energy pro tip. So first, the Bluetooth Low Energy part. When you are trying to capture a specific part of Bluetooth Low Energy data, let's say you have your app, you did the Wi-Fi setup process. What I would suggest you do is, after you have that data transfer that you want, close the app, and then immediately disable Bluetooth, right? Like kill it, and then you can pop into here, and then you just know you pop it, you throw in your filter here, and then you go all the way down to the bottom, and then the latest packet data is going to be the stuff you care about. Because sometimes you'll pull this log down, and you'll have days worth of a backlog of BLE traffic. So we are going to go to the top, and then I'm going to show you my Wireshark column that I always add. This is a non-standard Wireshark column here. So if you right-click up here on any of these columns and you go to column preferences, you can add a column here, and you can add in, you can title it whatever you want. But see this delta time displayed field that we're adding here. So what that does is that gives me this column that I call delta. And what that does is it shows the time difference between the previously displayed packet, in my case. Or you can just do any packet, but that kind of gets confusing when you have a display filter in place. So what this lets me do is it lets me scroll down, and then when I see a big number, that indicates that that's kind of the start of a fresh Bluetooth Low Energy, potentially a fresh Bluetooth Low Energy connection, or definitely if it's a big number, 1 second, maybe not. But if I scroll down here, okay, there's a bunch of delay between packets. That's interesting. Pretty sure I'm gonna find like a big one here. Let's go. Oh. All right, well it's not gonna, oh, I just saw one that was like 12. Okay, it's like 12 seconds. Oh yeah, this is perfect. Yeah, because this send read by type request, that's oftentimes the first request after you make a BLE connection that gets sent. And so again, this delta column helps you identify that fairly easily. So what we're going to do though is we are going to kind of scroll down, and so I've got a couple different views here, and one I just need to make sure that we can see and then my head's not in the way. So I have the raw data here, and so I'm going to highlight the BLE section here. And one thing I like to do is I like to just go down and I like to look and see if I can see ASCII, right? If I can see printable characters down here that are interesting to me. Now there's some that are kind of garbage here, but what I'm doing is I'm looking for anything that has to do with the Wi-Fi setup process, right? Because I know my SSID is CTech Astronomy. That's the testing one I always use. And you guys should know by now my password is my password for that network. So if you're ever in town, you can connect up to that. but we're gonna keep on going down. All right, I feel like I kind of know where it is. Hey, there we go. So we can see right here, in clear text, we have C-Tech Astronomy. Now, this is not sensitive by itself. That's just the SSID, right? Because if you think about it, what's probably going on is that the grill is performing a Wi-Fi scan to see what Wi-Fi hotspots are close to it, and then it's sending those back to the mobile app, and then displaying those, inside the mobile app screen, which is what it does during the setup process. And then it's letting you enter the password for one of those. So what I'm really interested in is when it gets sent back with the password. But we can see here that already we're gonna note some things that are going on here, and these are those services, right? So we already went over here and we said we can see these unknown characteristics, FFF1, 2, 3, 4, and 5, right? Those UUIDs. Well, we're going to see those in Wireshark. So now we can correlate the services that we see in NRF Connect with what we're seeing in Wireshark. So over here in Wireshark, we can see that we received a handle value notification. We'll talk about what that means on handle 0036, and that corresponds to FFF5. So our UUID 5 is what receives back this this thing that has to do with Wi-Fi. So one of the things we could potentially do is we could potentially and the handle is kind of just a corollary to this UUID. We won't go all the way into that, but just know that this handle is kind of synonymous with this UUID. It's a shorthand for it within the session. So what we can do, I think we can, say apply as filter and say and selected. And now it's only going to show us packets that are using that handle. And so we're going to go down, and there are some other SSIDs that are near me. And we see right here, we see a packet that says C-Tech Astronomy. And then there is a character in between there, a 1E character. And then MYP. And then let's look at the next packet. Password. Okay, so we have my SSID and my password all together there, sent in clear text over Bluetooth Low Energy, right? Now, you may not care about that because it might be a hard attack for an attacker to be there at the right time sniffing Bluetooth traffic, but this device is not bothering to do any kind of basic encryption of your Wi-Fi password. It's just flying through the air over BLE. That would be a finding that we would write up in a pen test report, right? So that is interesting, but that's an attack where the attacker, again, has to be there in Bluetooth Low Energy range, which of course that's the way a BLE attack is going to work. But also they need to be there at the right time when you set up the device. Now, fortunately for an attacker, this grill is so buggy that I pretty much have to reconnect it to my Wi-Fi about every time I use the grill. But we'll pretend that that is not a part of the attack scenario right now. So we're gonna keep hunting for some other vulnerabilities in the Bluetooth Low Energy system. So that was awesome. Now I'm gonna remove that filter and just go back to our Bluetooth Low Energy filter. And I want to keep going down here and see other things. Oh, so I want to describe this notification, right? So handle value notification is where this message is getting sent back from the grill to the phone. So a notification, and we can actually see that that is set over here, right? We can see that you can here's a characteristic. Here's the FFF5 characteristic, that the properties that are set on this characteristic are notify, read, and write. So read and write are pretty self-explanatory, right? What notify does is, if you're familiar with the publisher-subscriber model, right? Instead of me just saying read, 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 and then eventually I'll get data when there's something to be read. Instead, what you can do is say, hey, if you get some data, then tell me. That's what a pub sub kind of a data model is, or in this case, it's called a notify message. And so you can register kind of a notification, your intent to receive notifications, and then it will send that data to you. So we can do that here, and so we can actually look in the PCAP for when that was set up. And that's going to be earlier up in the process. So I just kind of know that this looks like the beginning of the BLE handshake and everything. And so what we have, somewhere here, it's going to request. Okay, so we're already receiving here. We want to, oh, you know what? The good way to do it is actually going to be to go set that handle, search again, and we're going to see that, yeah, it's not showing up. I'm not finding what I thought I was going to find there. So we're gonna keep moving on though. So we're get rid of that part of the filter. So as we scroll down here, we see we're getting lots of these notifications, right? It's not, and this one here, we can see this is a different handle. This is handle 33, and this is related to the service FFF4. So this is a different service, and we can kind of go to our thing here, and we can see that, okay, this FFF4 service only has the notify. So that's the only thing I can do. I can't write, I can't read, I can only register a notification handler and receive data when the grill has data to send to me. So, okay, we're back here. And we can see that, yeah, we're getting a bunch of data here. If we look in this value section here, yeah, like that part of the packet, we can see there's a bunch of different kinds of data that are coming through here. So what I want to do is I want to see if I could receive this data stream independently of the normal app flow. Again, so when I go up to the grill physically, there's a button, and the app instructs you. It says you must put it into like Bluetooth pairing mode, right? So you press some button and then it flashes and says it's in pairing mode. And then the app lets you, once it kind of detects that it's in that it's in that mode, it lets you connect to it and stuff like that in the app. But we can already see here that we can connect to it. We're still connected to it here, right? We can read and write to all of, a bunch of things inside of here, and I didn't have to go walk up to my grill and physically put it into pairing mode. So we already have a potential for a vulnerability here that even if it's not in pairing mode, we can connect to these services and we can receive these notification handlers. So what we're going to do is we're going to write a Python script. We're going to use a Python script. I've got a shell of one, and we're going to kind of iterate on it. That's going to connect to this service. First, what we're going to do, I kind of lost track of what we're going to do. First, we're going to jump a little bit into the Android application because we will get to that in a future video where we deep dive into this. So where I always go if I want to download a Android app for reverse engineering, obviously on Android this is a lot easier than iOS. You can just transfer the file from your phone, but sometimes I just like to go and grab it. So I grabbed a copy of it from APK Pure here, and over on my shell I pulled that into here. And then it turns out this is this format. This was originally called XAPK, which is basically just a zip file. So what I did was rename that file to a zip file, and then I unzipped it, and then I got all these other things here. And so the main app is this app.masterbuilt.apk, right? Your standard Android application file. And then using a tool called JADX, we decompiled that just like that to JADX and then the app. And that's what gave us this folder. And this was another test I did with some different command line flags and stuff like that. But what that does is we can go into that folder if I type that command correctly, and we can see we have resources and sources, and we go into sources and we see a ton of folders, and we have the source code to this application. So we're not going to go too far down this rabbit hole today, but I am going to search for FFF4, and we are going to see that we have a decompiled Java file here that's kind of defining all these UUIDs that are used in the BLE services. And so this is going to just be a nice place where I can copy this UUID. Obviously, I could get it from other places, but we're going to go back here, and we are going to work on a little script here called notify. And you can see I actually already have the UUID in the script. Okay, perfect. So what this script is going to do, this script is using the Bleak Python library. Now, Python tries to be as, operating system independent and universal, but when you're doing stuff with Bluetooth, it's kind of not going to be that way. But the Bleak library tries its best to be cross-platform. So this should work on any operating system, but your mileage may vary if you're not doing this on Linux. We have our UUID set. We define this notification callback handler. So what this is going to do is in the rest of our code, when we get a notification callback from the grill, it's going to print out a bunch of sender information, and it's going to, in hex, it's going to print the binary data. And then what we do is I have a function called write that is not named in a very accurate way, because what it's actually going to do is we're going to actually, it's a bunch of async IO Python code, but the key line here is we have this line right here where we start notify on the client, and then we pass it that UUID, which we defined, and this is what we extracted out of Wireshark, we extracted out of the Android app, wherever. And then we pass it a reference to this function up here. So anytime it receives a notification, it's going to call this function, which is simply going to print out the hex data, right? So that's what we're going to do, and then we're going to just like continue to do that for a long time. So then what we're going to do is basically we just take in the MAC address on the command line. That's the only one argument that we have in this program. And then all this does is it just calls this write function. So basically the program, it registers, it says, hey, I want to get notified on this UUID, and then whenever the grill sends it data, it prints it out. So we are going to we're going to remember the MAC address. Haha, there it is. Okay. History for the win. So we are now, again, connecting. Oh, you know what? I bet I need to disconnect from the grill here on the phone. So that way our script can connect to it and then gets that weird error. Here we go. Okay, so now we have connected to it, and we have this data flowing in from the grill. It's just streaming it to our Linux desktop here, which is pretty cool. So I'm going to Control-C that there, and we're going to examine some of this. So you'll notice that the packets all start with pretty much one of 3 hex bytes. We have B3, B4, and B5. So I think I have this hypothesis, right? Okay, so let's go back to our phone app here. So if I click on my grill, I have the internet connected right now, and so The grill should work. Okay, so the grill right now is registering 56 degrees Fahrenheit. So if we do a little math here, if we say, what is hex of 56? 38, okay? So that's the hexadecimal representation of the integer 56. So let's go through here and let's see if we find 38 anywhere. Oh, hey, there it is. Oh, hey, there it is. So every time, excuse me, that a packet starts with B4, then the offset over here at 0, 1, 2, 3, 4, that byte always seems to be representing the temperature. Now, obviously, it's probably a 2-byte field because the grill can go up to like 450, degrees Fahrenheit. So that is going to need to be a 2-byte field. So I don't know, if it's big endian, little endian. That's something we would obviously have to reverse engineer later. But for now, we'll just pretend it's a 1-byte field, even though it's obviously not. So what we're going to do is we're going to change up our script to say, okay, if, the data at spot 0 is equal to B4, then we're going to say, okay, some, variable, just call it V1, and we're pulling it from the 4 offset on the, it's the 4th, it's the, 5th byte or whatever in that packet. And then we're going to say print, and we're going to go format string V1, and then we're going to do V1. Okay, so, and actually we'll just call this temp. So again, to review what the script is doing, we're just saying, there's those 3 types of packets, right? And we want the packet to start with B4. And if that's the case, then we pull the 5th byte off and we print that out as the temperature. So there we go. Oh yeah, forgot to pass the MAC address. And we are successfully decoding the temperature, which right now is staying constant. Obviously, I have, over the night, it's the temperature's been dropping, actually. So I have been able to see that this is, in fact, tracking with this temperature in real time. And so what is so interesting is that you'd think like, oh, it's okay, but that's just what the app does, right? The app can work over Bluetooth. Well, no, the app can't work over Bluetooth, because if I go like this, right? If I close out of all of that, and then let's free up the Bluetooth connection, right? So that's not an issue. Oops, I forgot what I was going to do. Okay. So what I'm going to do is we're going to disable the Wi-Fi, right? So we're going to test a theory like, oh, maybe the app can directly BLE and grab the temperature data that way. So click into here. It spins, and nothing, right? So we can get more data through this BLE interface, right? This service, than the actual app can get, which is probably some kind of a data exposure vulnerability, right? Anyone on, it's like unauthorized acquiring of the current temperature of your grill if the attacker is within Bluetooth low energy range, which, maybe you care about that risk, maybe you don't. But in the next videos, what we're going to do is we're going to dig into a couple of other things. We're going to look at the Android app a lot more in depth, look at what data is being stored by the app. Is it being stored securely? I think we'll find some stuff there too. And then we'll look at the cloud communications out to the cloud servers by the grill device. that is all I have. Thank you for watching this video. This is a fun time finding these BLE vulns. Let me know in the comments if you like these kind of videos, if you want me to do more BLE stuff. Have a good day.